Welcome to today's session. As requested, I'm gonna make a small video, and when I say small, I mean like a one-shot video for the entire laws of motion. And basically, this module will contain these few things. First of all, let's talk about the introduction of the chapter, like what exactly does it entail. First law of Newton, second law of Newton, third law of Newton, followed by what are the different types of fundamental forces in nature, followed by what are their classification. Do we classify them as contact forces, non-contact forces? There's going to be discussion about gravitational force, normal force, tension force, spring force, friction force, and last but not the least, pseudo forces, right? So after we have discussed all of it, we'll wrap up the chapter by talking about how centripetal force, how some of these forces can also act as centripetal force. Okay, now going ahead, let us first start discussing the basic laws. Okay, but before that, I should wear my teaching goggles. That is the important part of these. Okay, without no specs, no teaching. So let us start with our first discussion on what exactly Newton's laws of motion are. Well, there's a few things I need you to understand before we even start the chapter, is that Newton's laws of motion had a predecessor. People like Galileo, people like Aristotle already had ideas about this. So I have a picture for you guys. This is the picture that I was talking about. Okay, here you can read this. This is a Newton's letter to Robert Hooke. If I have seen further, it is by standing on the shoulders of the giants. Newton being very humble here, he is telling how his laws are actually a successor to a lot of research already done. Enough about the introduction, let's talk about the laws themselves. The first law says if a body is acted upon by no force, then there would be no acceleration. Very nice. There would be no acceleration. Look, this is the mathematical version of it. There is a better way of explaining this by saying a body maintains a state of rest or of motion unless acted upon by a external force. Now that's a very fancy definition. Mathematically though, like how we will use it to solve JEE based questions is this: if a body is acted upon by no force, then there would be no acceleration. Mathematical implication: if F net, the net forces on a body, is equals to 0, A net will also be equals to 0. Well, that means a body which is like continuously moving, okay, will continue to move forever unless acted upon by an external force like this. This property is also known as inertia. This is known as inertia. Okay, so inertia comes by the virtue of mass. More mass a body has, the more inertia it has. Okay, now one thing I would like to tell is that forces are vector in nature. So that means you could say this for any one particular direction as well. Like if forces along x is 0, it would imply that the acceleration along x is 0. If forces along y would be 0, then it would imply acceleration along y would be 0. If forces along z will be 0, it implies force acceleration along z would be 0. So remember, force is a vector quantity. It depends on the direction, right? So the first law could be valid in either of the three directions, like either of like all of the directions. You could separately write those equations and it will still be valid. Now apart from this, what exactly no acceleration entail though? That's something that people fail to understand. If I say acceleration is 0, it could mean two things: either the body is at rest, but the other option is that the body could also be at constant velocity. Okay, that is something that you need to understand. Sometimes when I say acceleration is 0, people tend to ideate on the fact maybe the body is not moving at all, but it could be still moving. It could still be moving, but with a constant velocity. Acceleration is defined as the rate of change of velocity, so we are looking at no change in velocity rather than velocity being equal to 0 all the time, right? So that's Newton's first law, explained in as much detail as we could for a short video like this one. Okay, so let us move on to the next part of it. Okay guys, let us continue the application of the first law. You have understood the theory part of it, but can we understand the application of first law? That is something that we need to check. Okay, now for this I'm gonna have to make some diagrams here, so bear with me where I make some fancy diagrams. Okay, so let's say this is a block, control noise, another block. Okay, another block slightly bigger, kept just below it. Okay, one more block, this block is kept further below this. All of these different blocks, and let's make different blocks by changing their color, right? We need different colored bodies. Yes, 3 different blocks, each of different sizes, kept on the floor. This is the floor right here at the bottom. Okay, so let me give their masses as well. Okay, let me give the masses. This is a 2 kg block, this is a 3 kg block, this is a 5 kg block. Use Newton's first law to describe all the forces between these blocks. That is the question right here. Okay, so let's see if we can make the FBDs. Now if you don't know what FBDs is, FBD stands for free body diagram. This is a diagram of all different bodies in the system, but we'll be considering only the forces that are acting on the body, not the forces by the body, right? Now if I talk about the 2 kg block on top, okay, 2 kg block on top has 2 forces acting, right? 2 forces acting. One force is acting downward, M into G. Now this is the force that always acts in a downward direction, and here it is equals to 20 Newton. 20 Newton because 2 kg is 10 meter per second square, acting downward direction. Now there is also going to be a normal that is going to act between this surface, the surface between 2 and 3, and I'm gonna color code this just so you are able to understand. Like this, let's call this yellow. So the normal acting here, I'll show it upwards, right? Now this normal is acting on the 2 kg block, but it is acted like it's applied by who? Well, the answer is 3. The 3 kg block is applying this particular normal on the 2 kg block. Now from Newton's first law, I know the 2 kg block is at rest along the y-axis. Along the y-axis, green body is not moving anywhere, right? So AY is equals to 0. So this would imply from first law that summation of all the forces along y would be 0. Now what does summation stand for? It just means the addition of all the forces. Addition of all the forces, guys, addition of all the forces is equal to 0. So this would mean that normal plus 20 Newton, if I take upward to be positive, downward to be negative, then normal minus 20 Newton is equals to 0. Please don't forget forces are vector, so you have to follow the proper convention. If I take upward forces to be positive, downward forces need to be negative. So in this equation, n minus 20 equals to 0. So n becomes equal to 20. Okay, I have seen students say that sir, normal and mg are acting in 2 different directions. They are equal in magnitude and opposite in direction, and they start implying that this is third law. It is not. Okay guys, please understand that if you have normal equal to mg, they are equal and opposite in direction, it does not mean third law is applied. Please understand, third law ke liye you need at least 2 bodies to act. It is third law is applicable only when you have a set of 2 bodies and you're talking about the action reaction pair acting on both the bodies. So right here, make the difference between the first law and the third law. Okay, first law is acting on a single body. When the body is at rest, you are implying that the net forces are 0. From there you understood ki normal is equals to 20. Okay, what about the second block? I'm gonna do it faster than how I did the 2 kg and the 3 kg block. So then the 3 kg block, there is going to be a normal from the upward direction, and I'm gonna color code this one as well, but let me just write down 30 Newton here. Why the 30 Newton? Because 30 Newton is the weight. Okay, let's color code this one as red. This surface between 3 kg and a 5 kg block, let's color code it at red, right? So there's going to be a red normal. Remember, normal forces will always be because of contact surfaces, on the contact surfaces, right? Now the yellow force in the downward direction, this yellow force in the upward direction. Actually I should be showing it here. This is the proper area of application, but you have to understand forces have transferability. You can move the forces anywhere as long as you keep the direction and the magnitude same. So I hope you understood it. This is going to be the normal force, that 3 is applying on 2, and this is the same normal force, but this time 2 is applying on 3. Equivalent action reaction pair. This third law right here, this third law right here. Now normal acting downwards, red normal acting upwards. So if I also, let me give some numbers so that I don't confuse between them. If I know that acceleration along y is 0, then I'm gonna say summation of all the forces along y is 0. So again, if I write what for this, I'm going to write plus n2 minus n1 minus 30 is equals to 0, right? So that means n2, the red normal is going to be normal 1 plus 30 newtons. Now normal 1 is equals to 20, we have already found out. So 20 plus 30 is equals to 50. I leave the last block to you. Okay, but 50 Newton is the normal between the 3 kg and the 5 kg block. This is the application of the first law. Okay.